You may recall when we learned factoring that we had a pattern like number 1 that was called the difference of squares pattern. The reason it's called the difference of squares pattern is because this is a perfect square, this is a perfect square, and you're taking the difference of them. And when we went to factor that, there was a special pattern that was always x, x in the first spots. You did 4 times 4 in the last spots. And what always was happening is the inner and outer one were canceling each other out because one was negative and one was positive, which would give an inner product of negative 4x, an outer product of positive 4x, which gives you 0. And so it turns out that there is no middle term like we typically saw with factoring because the middle two terms of the FOIL canceled each other out. So this was the pattern that we just kind of memorized that always works with the difference of squares. You may recall, though, when we have a sum of squares, in the previous lessons we said that this was prime. As long as we're dealing in real numbers, it's true, this is prime. This cannot be broken into two factors that have real numbers in them. But now that we have introduced imaginary numbers and complex numbers, the bigger set, we might be able to factor this, and we actually can. And all you have to do is, it's pretty much the same thing as the difference of squares pattern. It has the x and the x. It has the minus and the plus. It has the 4 and the 4. But it also has an I and an I. That's the only thing that will work. And so until we introduced the letter I, which is the square root of negative 1, we were not able to do this problem. So let's see. Let's just check our answer and see if it FOILs out to be what we had to begin with. We have first times first gives us x squared. The outside 2 give us a positive 4xi. Then we have the inside 2, which is negative 4xi. And then we have the last one times the last one, which is negative 16i to the second power. Now, if we take this to another step of simplification, the middle two terms are exactly the same except for the sign, and so they cancel each other out and make a 0. Because of that, we can just cross them off, and we end up with x squared minus 16i squared. But you may remember that I squared, by definition, is equal to just negative 1 with no radical on it. And so we can replace the I squared with a negative 1. Therefore, when we do negative 16 times negative 1, we get positive 16. And this is the same thing we had when we started. So that proves that that actually does multiply. This factor times this factor multiplies to give you the original. And so when we're asked to factor something that is called a sum of squares, we're going to have to use I to make it work out. Otherwise, it would give us the wrong symbol in between the x squared and the 16, or it would give us a middle term that we don't want.